topic for today is features of object-oriented programming in Python. Software engineers continuously look for new approaches to software design and development to deal with increased complexity. The traditional procedure-oriented programming, that is POP, failed to show desired bug-free result with a complex program. The latest programming approach, object-oriented programming, that is OOP, offers a new and powerful way to cope up with this complexity. In today's video, we are going to discuss the features of object-oriented programming in Python. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed, kindly subscribe and press the bell icon. The topic for today is features of object-oriented programming in Python. Let us start with the introduction. As we know that the softwares have become more and more complex. So the software engineers, they look for new approaches to software design and development. So the traditional approach, that is using the procedure oriented programming, that is earlier C and other languages, they had the procedure oriented program. So that failed to show the desired bug-free result for complex program, because as POP is based on functions, there is no flexibility in programs that are implemented using these languages. And as the size of the program becomes large, it is very difficult to debug the programs. The latest programming approach, that is object-oriented programming or OOP, it offers new and powerful way to cope up with this complexity. Objective of OOP is clear, reliable and easy to understand program. And here the OOP operates on abstract values called objects, which can communicate with other objects using message pass, and it uses the data and functions which are combined together to give us more flexibility in programming, that is using the classes and objects. This is possible. So we are going to see that. Let us first have a overview of the object-oriented approach. So the object-oriented approach is a programming language model organized around objects rather than actions and data rather than logic. That means here object and data, they are more important than the actions and logic. So the OOP approach combines the data and functions that work on a single unit called class, and object comprises both data and functions, because the data describes the state and function describes the behavior of the object. And objects, they are nothing but the real world entities that have some characteristics and behavior, and they are the instances of the classes. So objects communicate with each other by passing messages, as shown in this figure. You can see here we have object 1, object 2, object 3 and object 4, and we are showing the arrows, that is for the communication between the objects. So the objects will communicate with each other by passing messages, and then they can pass the particular attributes using the messages. Now OOP follows the bottom-up design concept. That means it starts from the bottom and goes up. So first we are designing the classes, and then we can call the particular main program. The object-oriented programming approach is supported by many languages. One of them is Python. And then we have the Smalltalk, C++, Java, Ada, etc. In today's video, we are going to discuss the features of Python. Okay, let us see the concepts of object-oriented programming in Python. For good understanding of object-oriented programming concepts, okay, and to help in decision making when designing an application, we must understand the different concepts. So here we are going to discuss classes, objects, then methods, message passing, polymorphism, inheritance, containership, reusability, data abstraction, and encapsulation. All these concepts we are going to discuss in details. Let us start with the classes. Okay. A class is a user-defined data type which contains data members and member functions. So member functions, they are also called as the, and these methods will operate on the data members. So class can be visualized as a 3-compartment box. So here you can see the 3-compartment box. It will have the class name, then data members, and the member function. So here the data members, they are having static attributes, or we call it as the states or fields, whereas the member functions, they are the dynamic operations of the class. So they define the behavior of the objects. In other words, class encapsulates static attributes and dynamic behavior in a box. So we call it as a 3-compartment box. So class is a 3-compartment box where we have the data members and member functions, and there will be a class name for that. Then let us go to the next thing, that is the class members. So the members of the class, they are the data members and member functions or methods. So they are collectively called as the class member. As you can see here we have 2 classes. Name of the class is student, and it will have the data members, roll number, name, grade, etc. And then it will have certain functions or methods, get data, show data. Similarly, here we have another class, that is car. It will have the data members, color, model, price, and again some functions like get data, display, like that. So here the data members, they are the static attributes. Then the member functions, they are the dynamic behavior of in the class, and this name of the class, that is the identifier for the. Then let us go further. Here we have a sample class in Python. So this is a sample class with init method. So init, here this is a method similar to constructor in C++ language and Java language. So it is used to initialize the object's state. The method is useful to do any initialization you want to do with your object. And then we have another thing, that is the self. So this self is the first parameter which is passed to the method or constructor. This self, if we are not having any argument to the method, at that time we'll have to pass the argument self. So self argument refers to object itself, that is the object that has called the. So let us see how we can define the class. Say here we are defining a class person. So class person and then colon, so that will define the class. Person is the name of the class or class identifier. Then after that, now this is for the comments. So here we are defining the init method or constructor. So def underscore init underscore self and name. We are passing two arguments here, self and name. Then self dot name is equal to name. So this name is given the variable name, and then we define method, that is say hello method. The name of the method is say hello, and the argument here is self. Then we print hello, my name is, and then we use self dot name. So whatever name will be passing here, so that attribute will be coming here at this point. Then with this p1 is equal to person Ankit, we are defining object p1 and we are passing Ankit as name to this p1. Then we call the p1 dot say hello. So this method is called with this p1 dot say hello. So when we call this method, then when we run the program, we'll get the output hello, my name is. That is what we have printed here. And then this self dot name, we are getting it from this object. So whatever you pass, you want your name, come here, then just take any other variable like p2 and then person, put your name, say Anil, then you'll get hello, my name is as the output. This is how the sample class in Python is written. Then let us go to the objects. An object is a real world entity which has some characteristics called state and some behavior. State means nothing but the attribute, and behavior is nothing but the method which is associated with that object. Now here the characteristics of objects are represented by member functions of the class, as we have just now seen, and the object is a variable of class data type, that is user defined, and it is runtime instance of the class. That means when we run the program, at that time the representation of the class is done by the object. Say if we define a class student and then we create say 3 instances of the class student, Anil, Pawan and Rajesh. They are shown here. So when we are creating the objects, then we give the name of the object. Now here the name of the object is Anil, and then equal to, and then here we write the name of the class student, and then we have to give the bracket. Similarly, in this case we have given the name of the object as Pawan is equal to student and then bracket, and here Rajesh is equal to student bracket. So in this way we can create the objects, and we have shown the attributes associated with the object Anil. So roll number is 1, name is Anil, and grade is 7.5. And this get data and show data. So these are the methods which are associated with the class, and that's why they are associated with this object Anil. And similarly, here the attributes are roll number 2, name Pawan, grade 7.5, and same methods they are associated with the object Pawan. Then here the attributes are roll number 3, name Rajesh, and grade 6.5, and the same methods get data and show data, they are associated with the object. So the term object, it usually refers to instance, but then we may refer to it for a class or an instance of the class. Then let us go further. The next thing is methods. Now a method is nothing but a function associated with a class, and it defines the operations that the object can execute when it receives a message. So the methods, they are associated with particular object. Now in this code, we first define the class bird, and then we create an object parrot from this blueprint. Then we call our custom method, that is about me, with the object, that is parrot. Let us see how we can do it. So first here class, and then name of the class bird, and this object we have given, and then this is the method about me. Here the argument is self, then it will print I am parrot. Then parrot is equal to bird. So here we are creating the object of the class bird, and the name of the object is parrot. So now we can access the method with this dot operator, parrot dot about me. So when we write this statement, automatically it will print I am parrot. So that will be the output of the program or method. So as you can see here, when we want to say give any message, it is given with the help of the method. So when we are studying the message passing, here we have two objects that can communicate with each other through messages. Say an object asks another object to invoke one of its method by sending a message. For example, here the sender will send a message to the receiver to invoke its method. So here the message is get details of student roll number 1. So the parameter passed here is roll number 1. So the receiver object will open or invoke the method with this parameter, and then it will get the attributes associated with that is roll number 1. So here we are getting the attributes as this is the roll number, the name, then its course and batch, like that. We can get different say attributes for that object. So in this way, the passing will be done. So message consists of three aspects. There is receiver object, then name of the method from which we have to get the attributes, and the parameter that must be used with the method. So here we have given roll number as the parameter, roll number 1. So in this way, the message passing will be communicating with the objects with the help of that. Then let us go to the next thing, that is inheritance. Now inheritance is the feature of object-oriented programming where a class can inherit data members and member functions of another class. That means here, as we inherit some of the characteristics from our parents, same way the object-oriented programming has this feature, inheritance, where the features of class are inherited by the derived class. So here the parent class is called as the base class or the super class, and the child class or derived class, it will inherit the data members and data the member methods from that base class. As you can see here, we have the class person, and from this class three classes are derived. One is teacher, another is student, and another is staff. So in the colleges we have different persons, so all belong to say the class person, but teacher has different characteristics, the students have different characteristics. Similarly, the non-teaching staff, they have different characteristics. So but all are the human beings, so they are derived from one class, that is person. So classes are connected in hierarchy. So if we have this person class is at a higher level, then we have derived the student class, then again teacher class and the staff. So this is the class hierarchy. We can have another class which is derived from student or from staff, that is possible. Then this inheritance, it promotes code reusability, where you can create new class from existing class having some common property. So reusability means we need not write the code again. You write the code once and use it again and again. That is reusability. We are going to study reusability with the help of say function later on. So this inheritance, it here we are deriving the classes from a parent class or the base class. So we can have any number of derived classes from the base. Then let us go to the next feature, that is polymorphism. So poly means many and morphism means forms. So polymorphism means many forms. So as you can see in this figure, we have a single name for the function. Here draw is the name of the function, and it can draw different shapes with the same name, draw. So here we have the class shape which has the function draw. Then we have another object called circle. When we pass the radius as a parameter, then it will draw the circle. Then when we pass two sides as the parameter, it will draw a box. And when we pass say three sides, then it will draw a triangle. In this way, a single function name to perform different types of tasks. So this is called as function overload. So here the function draw is overloaded. That means it is not only performing one task, it is performing the task of drawing different objects. So polymorphism plays an important role in allowing objects having different internal structure to share the same external interface. The external interface is same, but internal structures will be. So polymorphism is used in implementing inheritance. So there again we can have the base class and the derived class with different parameters. Then let us go to the next feature, that is the containership or composition. The containership is also referred to as composition, and it allows a class to contain an object of different class as a member data. Now see, already we have studied the class. Now class has the data members and the methods or functions, but here the composition is a concept that model has a relationship. That means say for creating complex types by combining objects of other types. That means class composite can contain an object of another class component. So here we have two classes, composite and component, and this relationship has relationship. It is called as the has a relationship. So here you can see the diagram shows you composite class and the component class, and there is a arrow. So here composition is represented through a line with a diamond. This is the diamond at the composite class side pointing to the component class. So this arrow is pointing towards the component class. So the composite side can express the cardinality of the relationship. The cardinality indicates the number of valid range of the component instances the composite class will contain. So this will contain, here the number is given as 1. So it will contain one member of the component. So this is nothing but containership. It allows a class to contain an object of different class as a data member. So this composite class will have one data member of the. Then let us see the next concept, reusability in Python. The reusability is very important in Python because it the building programs that are reusable, that is given importance. Reusability means developing codes that can be reused either in the same program or in different programs. So write the code once and use it again and again. That is the concept of reusability. And in Python, reusability can be attained through the functions, then containership, as we have discussed just now, and inheritance. So these are the ways to attain reusability. Now in this example, we have shown how reusability is attained through a function. So here we are writing a function angle sum that calculates sum of internal angles of a polygon given a number of sides. We will accept one argument, that is the sides, number of sides of the polygon, and then it will return the sum of angles, internal angles. So let us see how it is written. So first we write the def, define angle sum. This is the name of the method or function, and the argument we are passing is sides, and then it will return sides minus 2 multiplied by 180. For example, if we have 3 sides, then 3 minus 2 is 1 multiplied by 180, we'll get 180. So sum of internal angles for a triangle is 180. Then next we print the sum of internal angles. Then this code, function code, we use it in our program. So here we are writing a for loop in the range 3 to 8. I is in the range 3 to 8. So then s is equal to angle underscore sum I. So this s will have the sum of the internal angles. That is the variable where the sum of internal angles is stored. And then we print the string of I. So we will take the string of I and then string of this yes will print, and this is the sides. So the output we'll get is sum of internal angles. This is the first print statement, and then for this we'll get, when the value of I is 3 sides, sum is 180, 4 sides 360, 5 sides 540, 6 sides 720, and 7 sides 900. So in this way, this will be the output. So here we have called the function again and again, same function again and again. So that is nothing but reusable. Then let us go to the last two features, abstraction and encapsulation. The abstraction refers to the act of representing essential features without including the background details. That is called as the abstraction. So here in object-oriented programming, we make use of the classes. So classes use the concept of abstraction, and here the attributes, list of attributes, is size, weight, cost, function, say, and different other roll number, so that is given, and functions to operate on these attributes, that is given. Since the classes, the concept of data abstraction is used, they are also called as the abstract data type. So adding the details and just giving the list of the attributes, abstract attributes and functions, that we call it as the abstract. Then encapsulate. So this is another concept or feature in object-oriented programming. So the object-oriented programming approach combines the data and function together into a single unit, that is, we call it as the class. So this feature is called as encapsulation. So encapsulation here means data is not accessible to the outside world, and only those functions which are wrapped in the class can access. That means it is acting as a capsule over the data and function. So only the data will be used only by those functions which are part of the wrapped in the. So that is again used to hide the mechanics of object, allowing the actual implementation of the object to be hidden, so that we don't need to understand how the object works. So what we need is only the interface that is provided to us. So we know the methods which are available for the different objects. So this is what is encapsulation. So abstraction and encapsulation, these are the two features which are the object oriented. So with this we come to the end of this video. If you have any queries, you can contact me on Facebook, Twitter, Gmail or Instagram. Then if you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon, because if you press the bell icon, subscribe and then press the bell icon, then you'll get notifications for our future videos on this subject. I'll be preparing some of the videos